Good afternoon, and welcome to the Music and Technology Seminar at Carnegie Mellon. Our guest today is Dr. Robert Pritchard, Professor Emeritus at the University of British Columbia. Dr. Bob, as he is known far and wide, is an internationally known composer whose works often go beyond a traditionally notated score. His research has included speech synthesis, infrared gesture tracking for media control, and the development of e-textile sensors, which are devices integrated directly into textiles, such as using conductive yarns or other materials to convert physical motion to acoustic sound. Please welcome Dr. Bob to the Music and Technology Seminar.
Well, thank you very much. I'm very, very pleased to be able to present this. I'm going to start by, as most UBC presentations begin, by acknowledging that the activities of the University of British Columbia take place on the unceded territories of these three nations. Today in Canada, it's a National Truth and Reconciliation Day where we reflect on the tragic and horrible history in Canada of the suppression of First Nation cultures and people. So here in Vancouver, for thousands of years, these nations have created and performed music and developed their musical instruments, and we're grateful that they continue to share their land with us, and we are able to develop our music and develop our musical instruments. So my compositional interests, not unusual. These are things I'm particularly interested in, and these five aspects carry various weights in different pieces of mine. My technological interests, generally, I'm working in these areas. The last three I'm particularly interested in, things being robust, inexpensive, and distributable. And my first example of this is none of that, but I do want to show that's a jumping off point. So GRASP, as we called it, this was a research composition performance project that was carried out in collaboration with Sid Fells in the Department of Engineering. Sid is one of the founders of the New Interfaces for Musical Expression organization, NIME. And this was based on his doctoral research that he did with Jeff Hinton. Some of you may know Jeff Hinton's name. He's one of the biggies in AI, artificial intelligence. He's also one of the people calling for a moratorium on the development until we actually figure it out. At any rate, this is the physical aspects of Glove Talk 2. It's got a magnetic source here with two sensors, one or two sensors. The sensor gets mounted on the back of the glove. This is essentially a garden glove with 8 copper contacts on it. And the height of the glove above your waist controls the pitch of the speech that's being created. The glove itself, the postures control vowels and consonants. And then this glove, the left-hand glove, controls the plosives, the voiced and unvoiced plosives. And in the horizontal plane, the movement of the glove moves through the vowel quadrilateral. This is old research. But I do want to show you what Sid's doctorate looked like. This is an example from Glove Talk 2, an excerpt from Dr. Seuss's Sam I Am.
Would you like green eggs and ham? I do not like them, Sam I Am.
Okay, so you can get speech off this, and it's controllable, understandable. There's actually a video of Sid and Sagiv, the person who's performing, carrying out a conversation about what they did on the weekend. At any rate, come back here. We developed this into divas. This is Marguerite Whitfoot, one of the divas. And here you can see in this picture the cyber glove. There's the tracker on the wrist, the black glove controlling plosives, and the magnetic source so that the tracker is being able to know the area and height. This is a picture from a performance that we did down in Australia. We've had performances all over the place, well, all over Japan, Australia, the US, and Canada, and then some demos elsewhere. This is an example of Marguerite performing. Now, in this example, because this was a research question, we took out the machine learning that was in the original one, which made the speech really much more easy to do. We took out the machine learning and a couple of other things, refactored the code. And so Marguerite it's a really tough job, and she does this. This is her, essentially, she and the glove performing. I want to point out, this is not a duet. You have two voices, but it's not a duet because there's only one brain.
What? Inside where there is
Okay, that's a very quick example just showing what's possible with the human brain being able to substitute for machine learning. But out of this, I got very interested in motion capture. And I started developing and working with others to develop tracking to control audio and video, processing, control DMX lighting, and also augment acoustic instruments. And Keith Hamill, the other music tech prof at UBC, used gesture tracking as well for working with automated score following in collaboration with his software Notability Pro. So these are the 5 projects I will talk about. I'll go briefly through these. One of the things I want to point out, this is Rub, Shrug, KiCASS, Taste, and Woozy. If you want to get the grant money, you've got to have good acronyms. It makes all the juries remember them, and it's been very successful for me. All of these were funded. Okay, so responsive user bodysuits, or RUBs. These started up when Kieran Bumber, seen here wearing the very first prototype, she came up to me after a concert and asked, how would you put sensors on a bodysuit? So we ended up using resistive and conductive fabrics. Those are available, like the soft pot kit from Adafruit and such. Many of you will know this. These are lily pads, a lily pad Arduino, which have been used a lot on clothing. And so you can see this is just a hack job we were running up in a couple of days. I particularly like this picture because 10 seconds after I took it, the conductive fabrics burst into flame on her back. Don't try this at home, okay? Anyway, that was the jumping off point. So as we continue to develop this, here you can see we've got conductive fabric, we've got resistive fabric here. And when you sew those in parallel on a bodysuit, you're forming a potentiometer. And then the conductive fabric on the gloves acts as the wipers on the potentiometer. And so as you scroll up and down, you're creating varying voltages. That gets sent to an Arduino where it's digitized and then it goes on to the software to control the processing. I submitted a RUBS piece to Copenhagen NIME in 2017. Margaret Lancaster was on the jury and she said, oh, no, I want you, she commissioned me to create this piece, The Memory of Your Touch. And this is her suit that she's wearing. This is in rehearsal in Copenhagen. Notice I said it had a long Ethernet cable. We were not wireless at that point. She had a 50-foot Ethernet cable, dragging it around after her. But the cool thing was, as I mentioned here, she started using her flute as the wiper on the potentiometers, which was kind of fun. Eventually, I developed a wireless setup, but then I supervised a group of engineering capstone students. The undergraduate engineers have to do a capstone, and they developed a much better Wi-Fi setup using Arduino MKR1000s. So this can handle up to 12 sensor inputs, and it's got a rechargeable LiPo battery, which makes it a lot of fun. Here's an example of Sarah Wasik performing on this. She's one of the student dancers. One side triggers samples and the other side scrubs through samples. The laugh at the end always kills me. So as the suits developed, we tried out different sensor layouts and different materials and continued to use the resistive and conductive fabric, but changed the types of fabrics as new things became available. The 2 suits in the center were used at Virginia NIME in 2018. I'll give you a quick look at Zine Kwan and Emelina Fredrickson. Now, there were no bed tracks in this performance. They are controlling all of the sound throughout the performance, which was a lot of fun for them and for me. The Margaret Lancaster's flute piece developed into The Memory of Your Touch. Well, one of our doctoral students, I commissioned him as a research project to create a piece for dancer and flute, and did that around 2017. And then in 2019, we had this presented at the ICMC in New York. This is Margaret Lancaster, very good New York flautist, and Sarah Wasick in performance. Okay, you get an idea of what's possible with that. We also, Kieran Bumber, who originally sparked the idea for the rubs. This is a piece she did at a South Asian Festival at Vancouver Art Gallery called Transmute. And I won't play anything from this, but I do want to point out she was the composer and performer. She was both the rubs performer and also used her clarinet in this. And the choreography was by Emmalena Fredrickson, who you've seen dancing. This was an incredibly popular presentation. We only did one performance of it, and in the gallery, over 200 people crowded into the performance space, and as a result, she couldn't do any of the choreography. And she was trying to work her way through people. And of course, the other thing you run into is you've got all of these cell phones that are trying to hit up your Wi-Fi network, etc. So it was a challenging situation for that performance. Now, Bernd Wehrstadt had seen Margaret Lancaster's performance in Copenhagen, and he'd also seen the dance performance in Virginia. So he approached me. He's an Oslo composer, approached me about collaborating on a piece. He works with Session, who was in Oslo at the time. She's now in California. And they wanted to work on a piece with me, so they flew to Vancouver, and we spent some time working on this rubs piece. So in this example, Session is controlling sample triggering and processing with the rubs. She's also got her voice involved in processing it, and Bernd is doing real-time manipulation of what she's supplying with the audio, and he's also working with the voice and the samples. So feel free to sing along with that as you go about your everything today. Now, out of these rubs, I took the idea and developed a sleeve-only version. And this is designed for instrumentalists who sits, like pianists or harpists, things like that. So this next example is Danielle Lee demonstrating triggering and scrubbing through the samples. And this was in preparation for the next piece I will show you. So here she's scrubbing forwards and backwards through sounds. And what we don't demo here is how she can also process audio in real time. Okay, so you get the idea. So that was in preparation for a piece that was commissioned by pianist Megumi Masaki, very good concert pianist, contemporary. She was also, for a while, head of the Banff Centre for the Arts. She's a prof in Manitoba. This is an apology piece to the Japanese-Canadian community, and it deals with another sad moment in Canadian history when Canadian citizens were interned in World War II. A parallel thing happened in the United States. And these citizens lost their houses, their belongings, businesses, and cultural artifacts. And through my family, I actually have connections to some of these people. And so the issues I'm dealing with are othering and disruption of lives. And so the shrug developed for this piece was developed in this manner for this piece, doshite, which in Japanese means why. So I'm using traditional Japanese lullabies. I'm using texts from letters that the internees had written prior to and while they're there, government announcements. And it's a difficult piece. It's complex. You don't get the full range of what's being asked here, but what I'm asking Megumi to do. But this next example, I've got two scenes showing her working with the shrug in this piece.
Maybe you'll go to Kaslo with the United Church Bunch.
British Columbia は自国です。British Columbia は自国です。
Maybe you'll go to Kaslo with the United Church Bunch.
Failure to comply with this order will entail a penalty of $500.
You know that you have nothing to do with this war.
Failure to comply with this order will entail a penalty of $500.
This war.
Why? Why? Why?
So another sensing system that we developed at UBC is what we call KiCASS. And it's using the Kinect for Windows version 2 interface, which you probably know as active infrared sensing. And you can track up to 25 points on a person with this, and it can also identify certain hand postures. Generally, we originally only tracked 1 or 2 dancers in performance, and you can see this is the Max MSP screen showing how you select the target points on a dancer or a musician in order to get X, Y, and Z coordinate data. And this just shows what the skeletons look like, what the Kinect is tracking. And this has been used in lots of different places, as I've mentioned here. And it's been for about 10 years fully integrated into our laptop orchestra, our subclass digital performance ensemble. And I say it's stable, dependable, very popular with the students. I joke that with those characteristics, it would make a great class valedictorian for high school. And here we have an example from Bang Festival. We have 2 festivals a year, Winter Bang and Bang. And here, this is called Happy Accidents. It's here the right hands of the dancers are being tracked by the KiCASS system, which you see right here. There's the sensor, the camera. It's tracking the right hands, and that will control drawing on a particle system that is being controlled by other data. There's a bit of a lag just in terms of all the processing going on. The particle system is in Unity. So this is going through the KiCASS software being then transmitted to Max MSP, which then writes the hooks into Unity. Okay, another example here is where we're using the node object in MaxMSP. The student, Brian Top, is using, and Brian and Shell are using the node object. This means that the stage is mapped out, and the dancer, when she crosses into a node, is able to trigger a pre-recorded sample, and those samples can then get updated. So she knows where the nodes are on the stage, and she's able to control the speed at which the piece unfolds just by walking into those nodes. Now, one of the things we've been able to do with KiCASS between Burnt and Session, we used Zero Tier to connect over the web. And so we had Session down in Santa Barbara, and her movements, her dance was controlling video processing over in Oslo and audio processing in Vancouver. And then we blended the signals to be able to create a piece out of that. So this was also used. Another student, one of my students did a connection between Vancouver and Cape Town, was working with a dancer down there. So out of this tracking in smart textiles environment, the taste, where we started looking at combining as many of these systems as we could. Now, one of the problems with the KiCASS system is that Kinect auto-assigns IDs to each performer. And so the system can get confused when dancers cross in front of each other. And so when they cross, the system isn't sure, did they actually cross or did they bounce off each other? And IDs can get confused between dancers. And when that happens, the dancer isn't controlling their own sounds or processing, they're controlling the other person's. And also KiCASS can't tell when somebody goes out of the tracking area, when they come back in, they don't know if it's the same person or a different person. So they give it a new ID, which means they've lost control of what they're supposed to be doing. So we decided we'd try using color tracking. And the first thing we bought was these ridiculous leotards that no professional dancer will ever wear in concert, because they end up looking like Playmobil figures when they start putting on dance pants and things like that. So in this, each dancer is controlling one of 4 different rhythms, and the rhythms get a little more complex. Their distance to the camera controls the loudness, and this is also a test of the software ability to discern the entries, exits, and occlusion. The rhythm tracks are all synchronized, so when they all blend together. So as I say, each dancer is controlling a slightly different rhythm track. So here's an excerpt from Cheap Loops from 2000. Out of this, we took a look at increasing the number of people, so built this up so we could track 6 people. And we also added MaxMSP's Mubu, so we could recognize certain gestures by certain dancers. So each dancer, we ended up being we're able to have control over 3 additional sounds not related to the rhythm track. And by carrying out those gestures while they were dancing and moving around, they were able to trigger those sounds. So here's a studio test during COVID or post-COVID. So lots of various things happening as we keep adding incrementally. And just to point out, as I often say, the incremental approach to working on projects is the best because it lays foundations for. Let's be mercenary about this. For getting more grant money, you can show you've been successful so far, and you have the street cred to be able to continue being successful. All you need is that money to keep hiring students and techs, etc. So we're looking at tech improvements. How could we improve the technology? And Daniel Tsui, who did his B-Mus and his Mus-M in violin performance, he went on and did a computer science degree, but he's also a self-taught electrical engineer, exactly the type of student you want to have in your studio. He designed a new multiplex board that would fit on the TTGO ESP32 microcontroller. So it's got 19 sensor connections, but he also added 2 power and data connections for addressable LED lights. It runs on a vape battery, and we can send data, we can broadcast data, LED data to all of the performers at the same time, and we can take in individual data streams from each, and we can update the boards wirelessly just by sending update code. Boards are professionally printed, but then Daniel had to do all the part soldering and micro soldering and getting the chip lined up. This turned into a side project working on spines, dance spines, and these spines are responsive to data coming from the sensors I've already been working with. The single spine has been used. I will show you that. The double spine's sort of in development right now. But during COVID, the Vancouver Turning Point Ensemble began commissioning films because they couldn't have concerts. So oboist David Owen in the ensemble, he's a friend of mine. He was the first person to be profiled. And because I'm a former oboist, he asked me if I would create a piece for him. And I asked, can we put a spine in this? And that got approved. So I created this piece called Synapses. Now, the time frame on this was so short that we weren't able to add the interactive control of the light spine from his sound, although that works. In this piece, David is also wearing an accelerometer on his wrist, and he triggers explosions by gesturing with his wrist. This is a really hard piece, lots of rapid passages and multiphonics in it. Alrighty, so out of this, a friend of mine, Philip Gorecki, was asked to create a piece, and I really love this. We were able to put together some technology, art technology, and other people go ahead and use that. And so Emily created commissioned him to do a longer piece that's performed in several places in British Columbia. Emelina also performed that piece outdoors. It was freezing. We're wearing jackets. We can see our breath. It's sometimes a light drizzle. And just the very short, this is Emelina in performance, lying on cold pavement. But it does show you the way the spine can do some cool things. Okay, so as part of this was an outdoor performance. I took the Kinect, and I did one of our Kinects, did a 3D scan of Emelina and deconstructed this into her cyborg character to show just as a symbolic thing. And then we projected this on the side of the building that was next to this performance area. I'll just show you a bit of this. Alrighty. Meanwhile, I'm continuing work on the dual spine. Actually, yesterday, day before, I just dropped it off on the set designer, the costumer who I work with on these things. And so we'll see where all of this goes. Now, another project, the second last one I'm going to talk about is voice. And voice, many of you are familiar with Neil Thapin's pink trombone, the articulatory synthesis on the web. We use Catan's open source JavaScript API version of pink trombone and wrote Max MSP software to interface with it. And here you can see there are the tongue target points here from pink trombone. This is the node object underneath, and the movement, we're doing hand tracking, controls where the target points in the tongue are being touched. And then over here, this is showing how the glottal, the articulatory aspect, the glottis, and how it is being controlled. Down below, this is the main Max interface. It's got the audio interface here. We handle stereo, quad, and octaphonic in our concert hall. These are UBC Toolbox modules. Now, this ended up with a bit of a collision between another project I'm involved in linguistics, drawl, which is determining regional accents with literature. And as part of this, we're studying the accent of the Okanagan Valley. I grew up there and I could recognize that in some of my students. So we got thousands of samples of phonemes. So in this case, I combined this. In this first example, you see Danielle using her hand to control the triggering of families of particular phonemes.
A, B, E, U.
And then this second example is what the pink trombone vowels sound like. And so forth. This is Mia Harris. She's an opera singer and an actor from the Okanagan Valley. Here she's using her first test with voice, and she's also adding her voice in here. The distance of her hand from the Kinect controls some of the breathiness, but she's also adding her own breathing. Okay, so that's kind of fun. Now, as an oboist, I was also interested in the idea of adding sensors to woodwind instruments. And we were originally looking at adding these to clarinets and oboes and putting FSRs inside the keypads. And this became really, really difficult. We worked on this for a couple of months. And then we started looking at the idea of putting the force sensing resistors, the FSRs, on flutes. Now, some of you may be familiar with the work of Cléo Palacios-Quintin. For about the past 25 years, she's been working with hyperflute. And this is a really sophisticated interface, very successful. These are the types of sensing that's available to a composer performer working with this. Very robust, and it has been very successful. And you can select what you need for your particular piece, and highly refined, works really, really well. But however, hyperflutes, the add-ons can be expensive, like about $3,000 to get that thing. And if you've got an $80,000 Haynes gold flute, most people are pretty hesitant about you starting to add things to it in performance. So some performances, you may need multiple instruments, depending on what you're doing. So part of Woozy is we want to develop an inexpensive system with no modification, easy to add and remove with very little changes to the performer's technique. So looking at flutes, we started with student models and abandoned those after trying some things. Professional flutes have 5 open hole keys on them, whereas student models are just flat. So we eventually came up with printing these 3D tone hole inserts that would have short tail FSRs on there. And then we have a new smaller ESP32 and a custom designed interface. And then we're able to just read the pressure off the FSRs as the performer is performing. So here you can see, this is what the type of data we're getting off the FSRs. You can see it's really smooth in terms of direction, etc. And then all of this is held in 3D printed box like this that clips on. There's the LiPo battery. There's the we get the ESP32 and the interface in that box as well. So from this, we can get values theoretically from 0 to 1023 on the pressure, and we get binary numbering depending on, you can count in binary by pushing down the keys on the flute. And if you want to trigger specific modes, you have to hold a certain combination of keys down for 1 second. You can adjust how long it is. And for triggering bangs, for max MSP, pressure values, they got to go above a certain threshold, and then before they will trigger again, they've got to drop below that threshold. So this is what the Woozy interface looks like. I created this data matrix specifically for it, and this are all part of the UBC toolbox. Something I'd like to point out for those of you working in Macs, often we have all of these tabs of the sub-patchers, and it's easy when you're working, when you're writing code, you click that open, then you close it. A really dangerous thing that can happen in performance is you might open it or click on it, but it doesn't open, it just opens to a window, and then you'd go and click on the red go away button for it, which is actually going to shut down your entire patch. So one of the things you can do is you can make it close, no close little patch that will control whether that red button is active or not, and you can turn it off during performance. So the audio processing, these are UBC Toolbox modules. These are all doing audio sends and receives wirelessly. You don't have to have your connections. Here's how the sample triggering works. So single bangs trigger samples. You can increment through families of samples. Here's the key pressure gets passed directly through. Here's the threshold that controls whether it's a bang or not. And we can do data recording, playback, and looping of anyway, I'll leave that. And then each section in the piece, you can have remote messaging. So for setting up presets and controlling, set this reverb time L, it's going to go, the L's tell you what value it's to go to and how many milliseconds it takes. So there's some really sophisticated messaging happening in the toolbox. And so here are 3 views of Woozies. Here's Paolo, the very first time he tried this on his flute. All right, you get the idea. I'm going to jump very quickly just to finish off here, talking about our minor in applied music technology at UBC. There are 18 core credits and 2 electives that you take as part of this. Interactive performance systems, that's our laptop orchestra. The computer music is Max MSP. In 419, you also learn some Unity programming. And then the capstone projects are the thing that really hold things together. The laptop orchestra, it's a 2-semester course. You code in, as I say, Max MSP and Unity. We've had 4 international trips for 2 weeks each to Belgium, England, and the Philippines. We do 2 festivals a year along with studio performances, and it's part of this. It's the ending of the minor. These are 3 examples of capstone projects in the recent years. Michaela Moon made this Michelody. She was a performance major in cello. So of course she's got 2 slide pots here to control pitch and other processing, and she's got strings here that have piezo vibration sensors on it. So this thing won't work unless you're bowing it. She's a real cellist. Nothella added FSRs to her French horn, plus some other sensors in there. So it was an augmented horn with audio processing. And Daniel Tsoi made 3D printed violins with, this was conductive PLA that he was using for the sensors here. This one used Velostat. And then he had his ESP32s on there as well. Okay, so that's in a nutshell the types of things I've been doing, and as I always say at the end, everybody ropes, everybody rides. Thanks very much.
So, any questions, comments?
I have a question, Dr. Bob. So
yes,
I've been playing with Kinect quite a bit, but I also know that Microsoft has discontinued the Kinect the production of the Kinect and started another line called Azure, and
Yes.
also briefly discontinued that one as well. Have you played with any other in-depth sensors, like depth sensor or infrared sensors that can be potentially a replacement for the Kinect?
We've played with a couple of other cameras, but generally, it's so cheap to get Kinects, and they're so like you can get a Kinect for $30 on Craigslist or something like that, and then you get a power supply for $50, and we give away the software for free. And then you just need to run it on an old $300 Windows laptop, $150 Windows laptop. So most people are just going that route. And because of that, because that's established, and because I've retired, no, I haven't been chasing any more work doing tracking. However, Ben Portson, who was at Greenwich when I was at Trinity Laban last year, doing some guest lecturing for a week and a half, working with dancers and musicians. He's continued to work with the software. He's now writing in so that it connects with Ableton Live, and I'm happy to share his name with anybody and email address if you're interested in chasing that. But on the other hand, if you want, we can give you the code. You can refactor it for whatever cameras you want to try.
Is the UPC toolbox available for?
Oh yeah, yeah. I could, Felix. I can send you the link to that. It's downloadable, and I'll also send you another set of toolbox that were part of a side project by Yota Kobayashi, who is now teaching laptop orchestra. He did some very, very good modules as well for processing, and so they all adhere to the same thing. They've got instructions inside of them. Although I don't know how those have all been updated, but they all have remote messaging and the same type of configuration, the formatting of data. Happy to share that.
Thank you. That'd be great.
I have a big question. So for the first two devices you use, is there like a device-related reason why the sounds tend to sound so harsh?
You mean a lot of that is the samples that are chosen in terms of very aggressive sound. And part of that may be the audio that's coming through. Yeah, blame the equipment, Bob. Blame the equipment. No, I mean, I don't know how the dance piece sounded with the dancer controlling the nodes. I don't know if that should be sounding very smooth. I don't think you're talking about that. Is that correct? So are you talking about the particular aesthetic, like in the oboe piece, or are you talking about the aesthetic that Session and Burnt were using in their piece, or
like they're of the first like 3 to 4 examples you shown tend to have like a pretty untuned, like it's not categorized as a tonality or like a scaled voice coming out. It tends to be like more it's caused a lot of dissonance, and it has these kind of like I would say it's digital, but it's like the hissing sound of electronics, things like that. That's come up to me. I don't know.
So for the clat synthesis, that is a characteristic of the clat synthesis with the divas. It has that vocal quality. That synthesis method is, oh good Lord, when was clat? Was that in the 1980s or something? It's a very old synthesis method.
1960s.
60s, thank you. It's a very old, originally an analog synthesis method. The clat synthesis we used that because that's what Sid used it, and that's why we started looking at the articulatory synthesis actually. And the pink trombone controlled by, there's other articulatory models now, controlled with AI could be a very, very smooth sound if you were going to chase speech. But as far as tonality, I've written for orchestra, I've written string quartets, I've written choral pieces, I've written chamber and piano works. For me, there's a time to write in tonal modes, and there's a time to have atonal or non-tonal modes. I want the whole breadth of expansion.
Roger, you look like you have a question.
Yeah, I wanted to give other people a chance to talk, but Bob, that was really wonderful, and
thank you.
I enjoy your atonal or your a pitch modes very much. Is beautiful stuff. Um, uh, yeah, I was going to say no. Never mind. So I wanted to ask, what's next, or what are you working on, or and other people at UBC?
Well, I'm retired now, but I'm still supervising a doctoral student and I think I'm working with a saxophonist on a FSR project in January. Megumi has asked for another piece. I'm working with Paolo on these flute sensors. We're trying to get something done this fall. Megumi has asked for a new piece. Marina Thibault, one of the world's top violists, she wants to use the dual spine in a piece. I can't imagine that right now. I can't ask a violist to roll around on the floor as a dancer. But I'm also interested, I've got some touch gloves. I'm interested in just doing some basic things with. Oh, by the way, if anybody wants cyber gloves, I'm trying to sell 3 wireless cyber gloves, $300, those ones we used. We're not using them anymore, and Sid Fells doesn't want them, and so I think you got to have Windows XP to run them. I'm not sure. Anyway, I just put that out there. I have a couple of other ideas for pieces. There's one piece I'd really love to be able to do. It's very difficult. It's another apology piece, and it's the Chinese Canadian community when they, for years, had to pay head tax. They weren't allowed to vote. Went through various things. And one of the things I've been trying to do is learn Cantonese, because there are these very sad poems that were written on the immigration walls, the immigration building walls in Victoria. They're called wall poems. I would love to be able to set those. And there are 2 ensembles in Vancouver who are interested in me doing that. One of them just came back from a tour of China. So we'll see if that gets done.
Great, thanks.
I have a question. Have you done anything, Bob, with guitars?
No, it's and as somebody who used to play guitar, no, it's the same thing as an oboist. I've never written a string quartet. It's too scary. I mean, a woodwind quintet. It's too scary as an oboist writing a woodwind quintet. And as a guitarist, I feel, oh my God, I don't know what I'm doing here. We've had lots of students do capstone projects involving, but it's a really good question. It seems almost, why not? And yeah. I did oversee a capstone project last year with a lutenist who put sensors down below the strings so he could then use FSRs to control things, and also a little mini micro joystick that he was working on to do pitch bends and things like that. But it's a really good question. There's opportunities for thumb control on the back of the neck and things like that.
See if you can get one of your students to do it.
Yeah, all it takes is time, energy, money, enthusiasm, and people.
I have one other question. Have you had somebody use this in an application that you had never imagined? Any of these techniques?
Any of these? Well, it's the KiCASS. I was surprised at the number of ways students have used that in performance. That I found really intriguing. And as I said, Ben Portsonen wants to use KiCASS to connect with Ableton Live, and that's not something I would have considered. I don't use Ableton. I'm the sort of person, if I'm doing a piece, I'm writing all my own software in Macs. So the idea, the networked connection between Vancouver and Cape Town, I found interesting in terms of what they were trying to do. And also somebody was trying to do some music education applications. That didn't work out all that well, as they often don't.
I just wondered if, having worked with a lot of government contracts, does the government ever call you for any?
Oh yeah, no. That's one of the things. Contracts. The grants are these are government grants, and they tend to be very much arm's length. You have to put in a report at the end to a jury of your peers, and it has to be confirmed. But once you have the money, what you do with it is up to you. I had a discussion yesterday, though, with Paolo Bortolucci, the flautist. He has some connections with one of the flute companies that may be interested in with these sensors, the flute sensors. And so that then, one of the things we'd chase is what's called a MyTax grant up in Canada with the universities, where you combine university research and industry. We don't have the same level and type of funding that the Pentagon distributes around the universities for whether it's cancer research or sensors or things like that. But we do have NSERC and SHIRC and medical grants. So Sid Fells is actually doing a lot of medical grants right now.
Okay, that was one of my questions, actually. Okay, thank you.
So Dr. Bob, you mentioned in passing, I think, of someone wearing gloves and playing the keyboard. And I'm wondering, does that by any chance spit out a score for something someone's playing on the piano?
Good question. No, because we cut off the fingers on the glove so Megumi could keep her touch, or other pianists, and Danielle Lee has done this. So the problem is we don't track the actual keys. Now we do have in our studio, we've got a Yamaha. It's a MIDI grant. It's not a disc clavier. It puts out MIDI signals, so we can certainly track it that way. Keith Hamill, when he tracks Megumi in his pieces, he's tracking her hand location over the keys because when you're playing one of his pieces and it's scored out, he knows where the hands are going to be, and the pianist can control the speed by how fast she's playing. It will track that. So he's able to track the location in the score. But we don't actually do transcription. We haven't set things up to do transcription. I got to say, I always make fun of Keith because his pieces he's done for Megumi, he's got her firing fireballs at incoming alien spacecraft and blowing things up. I keep saying, are you 14? Seriously? And he's just working on a new piece of two people running along. And if you get behind, an eagle comes and grabs you and carries you back. And the audience, using their phones, they can throw things in certain zones to slow down these people running. And meanwhile, she's going to be playing to keep these people running along, racing. I'm like, are you 14, Keith?
Other questions, anybody? Online, remote, present in the room, anybody?
Thank you very much. Dr. Bob, I think Dennis Platt was in the 70s.
Whatever. It's just like, well, I was going to say before my time, but it wasn't. Okay.
He was one of my teachers. But
oh, is that right? Oh, very cool.
But the commercial product didn't appear till a little bit later in the 70s. And unfortunately, he died young. Okay. Possibly because of a lot of his early work, which involved x-raying the throat to
of course. Oh my god. There's an old, never mind, well, that's going down memory lane and opera training. No, I'm not an opera singer, but opera training, and a movie called The Vibrating Larynx and things like that. Oh my god.
Okay, Dr. Bob, I want to thank you very much for being here today. I want to point out two other things. One, that you were actually on Carnegie Mellon campus for NIME many years ago.
Yes.
But we must have met at that point.
I'm sure we did, but okay, I'm old. I'm an old guy. My memory is wow. So I'm sure we did, but it would have been sort of in passing.
Right. That would have been 2006, 2007, about then.
Yes.
And Jeff Hinton, of course, used to be here.
I didn't know that. So he went up to Waterloo from there, I guess, did he?
That's right.
He left Carnegie Mellon, he told me, because he was unhappy with the nature of government funding of the CS department.
So let me move to a country that's poorer. Okay.
Well, but cleaner.
Okay.
And the other thing I want to point out.
You did all right.
You did.
Nobel Prizes.
Were arranged to get Dr. Bob to do the seminar. Felix spent many years right down the street from where Dr. Bob was teaching.
Yeah.
Yeah.
But he was fortunate that he never ran into me. Okay, good for you.
So we're glad that he didn't, because he might have gone there instead of Carnegie Mellon.
Oh, yeah. I know he's very happy there. Very, very happy there.
I think so. Okay, thank you very much, and we'll be in touch again.
Thank you. I really appreciated the chance to share this.
Thanks.
Okie dokie. Everybody ropes, everybody rides. Bye for now.
Bye.
Were you at UBC or from